It is the longest water slide in the world. With 600 meters long, the top speed can reach 30 miles per hour and takes 1.5 minutes to finish the slide. In the engine, the crankshaft and the camshaft can rotate 5,000 times per minute, produce 2 to 300 Nm of torque. The temperature at the moment of ignition can be as high as 2,000 degrees Celsius. Drive the piston to reciprocate 10,000 times per minute. Why the engine not scrapped due to such intense friction? What is lubrication? Seemingly smooth surfaces are in fact not smooth in the microscopic view. There are many sharp and rugged asperities. All loads are actually spotted by them, so it leads to cases like elastic and plastic deformation, fracture. Under extreme conditions, such as high temperature, high pressure, materials may soften and melt, which cause cold welding and seizure. So, it is needed to use lubricant to avoid them. A lubricant functions by interposing itself between the surfaces in close proximity and moving against each other to cover those asperities and generate a low shear strength film for reducing wear for one or both surfaces. There are three kinds of lubrication regimes: boundary lubrication, mixed lubrication, and hydrodynamic lubrication. Most machines are designed to operate in hydrodynamic lubrication. Theoretically, because the oil film is thick enough, contact will never occur between two surfaces moving against each other. But boundary lubrication is a special case. During startup and shutdown period, machines will operate in this regime. This could be due to the requirement of the moving parts reaching a velocity high enough to entry lubricant into the contact, or because the oil pump needs time to circulate oil and reach all areas of the machine. So, why they can't stop turning? Because there is sufficient water between their butts and the slide. The water between your butt and the water slide functions as a lubricant to reduce friction and wear. If you slide down at this speed and without water, you will get hurt. But just a reminder, keep safety first even when playing water slide. Never stand at the bottom of the water slide. Okay, let's talk about another term, viscosity. According to the Newton viscous fluid flow model, viscosity of the fluid is its capability to resist shear deformation. A viscous fluid can be assumed consists of multiple very thin layers, and relative sliding happens between adjacent layers. Assuming that the surface moves at a constant speed, the sliding velocity of each layer reduces linearly if they are parallel. So we can get the rate of variation of shear strain. Assuming that the upper surface area of the lubricant is A, the drawing force on the uppermost layer is F. Then we can get the shear stress tau acting on the layer. The rate of variation of shear strain into shear stress is dynamic viscosity. Then divide the dynamic viscosity by the density of the fluid, we can get the kinematic viscosity. For lubricant oil, the greater the kinematic viscosity, the more viscous the oil, and will generate bigger resistance to deformation and thick oil film. Let's conduct an experiment. When I put the coin on honey, there is no sound, but when I put the coin on water, when playing water slides, water can play a role, but in the experiment, the viscosity of water is too low to separate two surfaces. No, I didn't say it. Let's do another experiment. As you can see, there was nothing in the truck. The sledge was pulled by a spring dynamometer and moved forward. Contact occurred between skating blade and the inner surface of the truck. The needed drawing force was about 0.4 Newton. Then I added some honey into the truck. At 20 degrees Celsius, the kinematic viscosity of the honey is 1 to 2,000, but for water it is only 1. Was the drawing force reduced? No, in this case, the drawing force was about 0.7 Newton. Although the high viscosity can make two surfaces difficult to contact, it also makes the resistance against two surfaces greater. Only the most suitable lubricant is the best. Besides, temperature also has a great influence on viscosity. Let's do another experiment. This drop of honey was what I just took out of the refrigerator. This drop was at 30 degrees. It is obviously that the drop with a higher temperature flowed faster. It is a kinematic viscosity temperature chart launched by ASTM. Based on engineers' research over the past century, we empirically find that the natural log kinematic viscosity is proportional to natural log temperature. Yes, at first, people only knew that the viscosity of a liquid decreased with temperature, so engineers found two problems. People might mistakenly think that all oils have the same viscosity at high temperature. Then, the viscosity of some lubricant is too high at low temperature and it can't be displayed due to the size limitation of paper. To improve this situation, in 1921, Mr. Neil McCall, an engineer of Texas company, modified the coordinate and made curves into straight lines. Now, it's much more convenient to use engine oil. Just look at the label. For example, this one, the number before W means low temperature fluidity. 5 means it can be used at minus 35 degrees. If it is 0, it means it can be used at minus 30 degrees. The number after W means the kinematic viscosity at 100 degrees. The higher the number, the higher the viscosity. Compared with low viscosity oil, the engine wastes more energy due to the resistance of the lubricant to deformation, but the benefit is that it can generate a thick oil film to protect the engine. The lubricant oils on the market are actually similar in composition. They consist of around 80% of base oil and 20% of additives. Additives mainly include antioxidants, anti-wear agents, anti-foaming agents, rust and corrosion inhibitors. There are three main types of base oils: mineral oils, semi-synthetic oils, and synthetic oils. But in fact, they all made from crude oil, just with different processes. Besides, there are many solid lubricants, such as molybdenum disulfide, graphite. Those are their molecule structures. They have high stress within each layer, but low shear stress between layers. Very similar to this, isn't it? Let's do another experiment. A deck of cards can support a vertical load, but with the transverse force, cards can slide easily. Solid lubricants have many uses. For instance, in daily life, the lock. If using lubricating oil, the dust in the air may be stuck and block the keyhole. And there is another common material,
polytetrafluoroethylene.
It is also called Teflon. The most common application in daily life is non-stick pen. Besides, it is widely used in thread seal tape, windshield wiper blades, and waterproof jackets. Because its coefficient of friction is usually about 0.04, which is one of the lowest among known materials, and it hardly adheres to any material. Even a gecko can't climb on a non-stick pen. It must be clarified that Teflon non-stick pen is not hazard with appropriate use. According to a report from United States National Center for Biotechnology Information, a previously healthy 29-year-old Japanese man presented with fever, dyspnea, and non-productive cough after wrong using. he put the pan on fire for 5 hours. When he was cooling the pan, a large amount of teflon was inhaled by him along with the water vapor, and he recovered on the third day after receiving treatment. The research of tribology can be tracked back to 500 years ago. The study of Leonardo da Vinci. He inferred through experiment that friction is proportionate to the applied load, and hypothesized that the force of sliding friction is independent of the apparent area of contact. In 1699, the French scientific instrument inventor and physicist Guillaume Amonton proposed his rediscovery of friction, and his law of friction was verified by Charles Augustin de Coulomb in 1781. Today, their theories are still widely used. However, the term tribology was not proposed by the British Ministry of Education and Science until 1966, and there is still much space for development in tribology in many aspects. For instance, lubrication for space. As mentioned before, most of the lubricant-based oil comes from crude oil. Space radiation such as X-rays, ultraviolet is very strong. They will destroy the molecule structures of those organics. Besides, biotribology is also a key research area, like the superhydrophobicity of lotus leaf. Moreover, to angioplasty, the blood may lead to wear of stent, and artificial joint contact lens. Furthermore, those crude oil products can cause serious damage to the environment if they are not handled properly. Environmentally friendly lubricants and lubricant recovery technologies are still need to be developed. Besides, in many cases, lubricant oils have the function like cooling, carry away debris particles, corrosion prevention, and shock absorption. Improving the composition of lubricating oil and make it can be used for multiple purposes is also the direction of scientists' research. According to a research of University of Southampton, problems with friction, wear, and lubrication causes losses of £24 billion to the UK every year, almost two-thirds of Britain's military spending in 2019. However, in some cases, it is needed to eliminate lubricant. According to the report of University of Sheffield in June 2020, the coagulation of tannins from leaves and dissolved iron ions will generate a substance with very low coefficient of friction, iron tannate, which leads to the coefficient of friction between wheel and rail down to 0.01 to 0.05, similar to Teflon or the friction between ice and ice skating. The annual speeding of transport of wheels of repairing damage to trains and trucks from Liverpool is over £10 million. So, problems about when, why, how to use lubricant. Hope this video can give you a basic understanding of tribology and lubrication, and hope you can join the tribology research group.